Hello students, these are the Bodhee Prep topic tests for QA. Now these tests are designed to help you evaluate your test readiness, and therefore it is advised that once you have completed the basic concepts and gone through the questions for a topic, you take this test. Once you've taken the test, then go through the video to understand or get a perspective of the level of difficulty of the test questions, the kind of time that could have been put in for a test. If you do like the test and find them useful, there are more than 200 topic tests available on the Bodhee Prep Android app. The app link is in the description of the video. To download the app and get cracking on the tests. This video is about the topic remainders. This is test number 3 as per the app. Overall, this was a moderate level of difficulty paper test with 10 questions, and an attempt of net correct attempt of about 6 questions would be a pretty good attempt. The time taken for this set will be a little on the higher side, and therefore about 25 minutes would be the time that you might end up investing in getting all the questions attempted, and from there therefore getting about six net correct answers. So that would be a good attempt. If we do look at the questions, question number 1 says there are two arithmetic progressions a and b such that the nth term are given by, for a n it is 101 plus 3 thrice of n minus 1, for b n it is 150 plus n minus 1, where n is a set of natural numbers. The first 50 terms of a and b are written alternatively, a1 a2 a1 b1 a2 b2 and so on till a50 b50. What is the remainder when the number is divided by 11? So if we start by writing a1, putting the value 1 here, this will be 101. b1 will be 150, putting n1 here. This is a1, this is b1. For a2, we'll just increase it by 3, because if you put n is 2, 2 minus 1 is 1 into 3 is 3 plus 101 is 104. This becomes a2. B will increase in steps of 1, so this becomes 151. Then is 107, 152 and so on. The last term of the series will be a50. So putting 50 here, 50 minus 1 is 49, 49 into 3 is 147 plus 101. 257, this will be a50. Putting 50 here, 50 minus 1, 49, 199. This will be b50. Now we know that the divisibility test for 11 is that we take alternate numbers, add them, and then take the difference. Similarly, the divisibility test for 101 is we take from the units place, we divide the number into groups of 2 and then take the alternate difference. For 1001, what we do is we make groups of 3. So from the last place or the last digit, we make groups of 3. By default, what will happen is all A terms and all B terms will be in one. It will be together. So all the B terms will come together, all the A terms will come together. That is, if I start from the unit place and I start adding B50, B49, B48 and so on, B3, B2, B1, alternate terms get added. So basically we get the sum from 150 to 199, B1 to B50. Then we look at the alternate terms A40, A49 and so on, A3, A2, A1. So we get the sum from A1 to A50, which will be 101 up till 257. If you look at this term, number of terms is 50. First term 150, last term 199. Here if you look at it, number of terms is 50. First term 101, last term 257. This will become 57. 140, 49 into 3, 140, 140. So this will be 258, not 247. 240. I've written the last term wrong. I'll just correct this in a minute. The last term for A50 will be 49 into 3, which is 147 plus 101. So 248, not 257. Added the 1 in the wrong place. Now it is fine. So if we look at the sum, this will come out to giving one on this side 200 plus 149. So 50 by 2 into 200, 349. Here also the sum will be 50 by 2 into 349. So as we see the difference of the alternate difference of the sum of the alternate terms starting from the unit test and the tens place, digits taken 3 at a time comes to 0. Therefore, like we do for 11 with 1 digit, we are doing for 1001 with 3 digits. So we can say this entire number is divisible by 1001. Anything that is divisible by 1001 will also be divisible by factorizing 1001, 7 into 13 into 11. So anything that is divisible by 1001 will be divisible by 7, 13 and 11. Hence this number is also divisible by 11. I would call it a difficult question, and 3.5 minutes easily to attempt this question for the simple reason that the concept will not be known to everyone and figuring out becomes a challenge. After that also there are chances of a mistake happening unless you're able to see that the difference in the first two terms here is 49, and again it becomes 49 for the last two terms. Spotting the solution may be a little difficult. So I'm saying difficult question may not be something that we pick up in the exam outright. The remainder then 15 raised to power 23 plus 23 raised to power 23 is equal to 19. A raised to power n plus b raised to power n is divisible by a plus b when n is odd, and therefore 15 raised to power 23 plus 23 raised to power 23 is divisible by 15 plus 23, which is 38. 38 is nothing but 9 into 2, and therefore, since this is divisible by 38, also divisible by 9, so remainder 0. Easy question, shouldn't take a minute to answer this question if it does show up in the exam. What is the remainder in the product? 1998, 1999, 2000 is divided by 7. Now 1998 divided by 7 is 2s are 14, 5 9, 8s are 56, 3 8, 5s are 35. So when divided by 7, this leaves a remainder of 3. Therefore, this will leave a remainder of 4 and this will leave a remainder of 5. Therefore, the overall remainder will be 3 into 4 into 5, which is 12 5s are 60. 60 divided by 7. 60 divided by 7 will leave a remainder of 4. 7 8s are 56. Again, a straightforward question, very, very easy concept. Even if you take time to divide and multiply, shouldn't take more than a minute and a half or maximum 2 minutes to solve. What is the remainder in 5555 raised to the power 2222 plus 2222 raised to 555 is divided by 7. Okay. Now, if we look at 5555 divided by 7, this would be remainder wise. Just dividing and checking. 7 7s are 49. 6 5s, 7 9s are 63. 2 5, 7 3s are 21. So 4. So when we divide this by 7, we'll get the remainder as 4 raised to power 2222. 4 cube. 863. So from here, if we take out 4 square and write 4 triple two 0, divide by 7, so this is 4 square into triple two 0 divided by 3. Basically, I'm trying to write 64. Triple two 0 divided by 3 is 7 3s are 21. 740. 120. So 4 cube into 740. This is 4 square into 64 raised to power 740. 64 by 70 is the remainder of 1. So from here we'll get a remainder of 16. Now we look at 2222. 2222 divided by 7. 7 3s are 21. 1 2 7 1s are 7. 5 2. 7 9s are 7 7s are 49. So remainder 3. So this will give a remainder of 3 raised to power 5 5 5 5. 3927. 3927. So if we take out 3 square from here, we are left with 3 raised to power 5553. So this will be, I'm again trying to take the cube of 3. So 3 ones are 3, 2 5, 3 eights are 24, 1 5, 1851, 30, 5400, 3. This becomes 3 square into 3 cube into 1851. 3 cube is 27. 27 raised to power 1851. 27 raised to power 1851. 27 is 28 minus 1. 28 is divisible by 7. So from here, the remainder will be minus 1 from this part. Minus 1 raised to power odd. So we can say 3 square 9. Because of minus 1, remainder is 6. 9 6 are 54. 54 divided by 7. 7 sevens are 49. So remainder is 5. So from here, the remainder is 16. From here, the remainder is 5. 6 plus 5 is 21, which, of course, we will divide further. 6 plus 5 is 21. 21 divided by 7 is 0. So for this entire thing, the remainder is 0. Again, this is the longest way possible to do the question, and easily 2.5 minutes to find the answer easily. But again, the concept is not very difficult. Calculation might take time. The first 23 natural numbers are written in increasing order beside each other. 1, 2, 3, 4, 5 till 23. So almost what is the remainder in this one? You have to 18. 18 means divisible by 9 and 2. Now, if we look at this number, the sum of digits will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Here there is no problem. Then 1, 0, or let us write 1, 0 here. Then we write 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 will add up to 45, which is divisible by 9. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9 will add up to 45, which is divisible by 9. So we are left with 10 ones in the ones place. So we write 10 plus, from here we have 20, 2 plus 0, plus 21, which is 3, 22, which is sum of digits 4, 23, sum of digits 5. 5 plus 4 is 9, 2 plus 3 plus 1 is 6. So basically, if we add the digits of this number, we get 6. So if suppose we say the number is n divided by 9 gives a remainder of 6. Also, if we divide the number by 2, clearly the last digit is 3. The remainder will be 1. Now we have to find out the remainder when n is divided by 18. The answer will be the smallest number which satisfies both these conditions. If we look from the options, 1 divided by 9 is a remainder of 1, 6 divided by 2 is a remainder of 0, 12 divided by 2 is a remainder of 0, so answer becomes 15. Because 15 divided by 9, remainder is 6, 15 divided by 2, remainder is 1, so both these conditions are satisfied, hence D becomes the answer. Again, in terms of level of difficulty, I'd say moderate difficulty. Finding the sum of digits might take a bit of time. After that, it is just based on the basic concept of combining the denominators. M is equal to 76 raised to 2006 minus 76. Find the remainder and M is divided by 100. Now 76 raised to power anything ends in 76. 76 raised to power anything ends in 76. Because when we multiply 76 to 76, we get 76 in the end. If we write this number, the last two digits will be 76. From here, we subtract 76. So we'll get a number which ends in 00. This will be M. Anything that ends in 00 is divisible by 100. Hence, the remainder is 0 when M is divided by 100, and that is the answer. We can try to look at other methods as well. But the point is, since we have, when we look at cyclicity, we realize the cyclicity of 76. Therefore, just using that, it becomes a one-step question. And therefore, I'm saying at most moderate, but will not take too much time to solve. What is the remainder in 2 raised to power 100 is divided by 25. Again, 2 raised to power 100 can be written as 2 raised to power 1000. This can be written as 2 raised to power 10 bracket 100. This is nothing but 1024 bracket raised to power 100. 2 raised to power 10 is 1024. 1024 when divided by 25 will be 1025 minus 1. And therefore, we can see the remainder here will simply be minus 1 raised to power 100, which will be 1. Hence, the answer here is 1. We can also look at the last two digits of 2 raised to power 1000, which will come out to 76. The multiple of 25 before 76 is 75. So from there also we can get the remainder 1. But in either case, I think easy question, at max moderate, but could be done, should be done within the 2 minute timeline. Fn represents the sum of digits of n, where n is 1, 2, 3, 4. The remainder in f1, f2, f3, and so on till f100 is divided by 90. What we can do is we can write the sum from f1 to f9. This will be nothing but 1 plus 2 plus 3 plus 4 up till 9. This will be 45. Sum from 1 to 9. Then we go from f10 to f18. Basically, we are going from multiples of 9. So that we are able to figure the 90 out of 9, 9 out of 90, and then we look at what we need to further. 10 to 18 again will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. This will also be 45. From F19 onwards, things will change. For the first two series, it was 1, 2, 3, 4, 5, 6, 7, 8, 9. The sum was 45. The next series also 1, 2, 3, 4, 5, 6, 7, 8, 9. The sum again was 45. For this series, it will be 9 plus 1, 10. Then 20. 2 plus 0, 2, 3, 4, 5, 6, 7, 8, 9. So instead of 1, we have a 10. So that sum will increase by 9 points. It will become 54. If we look at F29 to F36, now here we'll have two terms, 10 and 11. From there, 3, 4, 5, 6, 7, 8, 9. 29, sorry, 20, now we're looking at 28. 28, 29, 30, 31, 32, 33, 34, 35, 36. So this sum will further increase by 9, become 54 plus 9, 63. From, this is 36. From F37 to F45, the first three terms, 10, 11, and 12, 37, 38, 39. After this, 40 will be 4, 41 will be 5, 6, 7, 8, 9. The sum will increase to 72. This will keep on happening. So for series ending in F54, the sum will be 81. For 63 ending series, it will be 90. For 72 ending series, the sum will be 99. For 81 ending series, the sum will be 108. For 90 ending series, the sum will be 117. For 99 ending series, it will be, this will start from 91. So 10, 11, 12, 13 up to 18. This will be 126. Clearly, all the sums are multiples of 9 for sure. Therefore, F1 to F99, the sum when divided by 9 will be divisible because all the numbers are divisible by 9. So if we look for the sum from F1 to F99, this is divisible by 9 for sure because all the sums individually are divisible by 9. If you look at the last digit, 5 plus 5, 10, 14, 13, 17, 19, 20, 9, 8, 17, 7, 14, 17, 20, or 6, 30. So F1 to F99, the sum ends in 10 or ends in 0. So it will also be divisible by 10. So if you look at the entire sum, from F1 to F99. It is divisible by 9 and 10 both, so divisible by 90. So the only part that will remain is F100. F100 will have a value of 1, which divided by 90 will give us a remainder of 1. So the required remainder or the answer in this question will be 1. I think in terms of level of difficulty, the question is moderate. The only confusion that can happen is sum of digits versus the sum of numbers. Apart from that, no heavy concept used as such. But yes, calculation time will be required. With the addition of Min into Super Smash Bros. Ultimate, okay, Super Smash Bros. Ultimate, there are now a total of 80 characters in the game. Assume that the players are identical. Player 1 picking Mario, player 2 picking Luigi is the same as player 2 picking Mario, player 1 picking Luigi, and that any character may be picked by multiple players. Okay. Let P be the number of possible character selections for an 8-player game of Smash. Find the remainder and P is divided by 9. Now, in this, what is happening is suppose the characters are x1, x2, x3, x4, x5, and so on up till x80. The number of people who select that character will take that value. For example, if 5 people select x1 and 3 people select x3, we will give 5 to this, 3 to this, 0 to everyone else. So that will be a selection. Now the number of selections, that is the value that each of them get, has to add up to 8. Any solution of this equation, or this is a concept from permutation combination, any solution for this equation will give us a selection of characters because the players are identical. Therefore, which player chooses which character and when does not matter. The only thing is how many players have chosen a given character is what matters. So in this case, the number of selections possible will be, the sum of selections should be 8. Therefore, we can say 80 plus 8 minus 1, C8 minus 1, which is 87 C7. So this will be 87 into 86, counting back 7 numbers, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7 divided by 7, 6, 5, 4, 3, 2, 1. Using the concept of permutation combination, this is the value that we get for P. 7, 6 are 42, 2 are 84, this goes away. 5, 17 are 85. 3 27s are 81. 4 2s are 41. And 2 4s are 80. 43s are 80. So the value of P comes out to 87 into 43 into 17 into 83 into 41 into 27. 70. Find the remainder. P is divided by 9. If we divide P by 9, P is a multiple of 27, so P will be divisible by 9, and the remainder should be 0, and that becomes the answer. I think more heavy on the permutation combination part rather than the remainder part. Remainder played a smaller part, and therefore, as far as the remainder concept is concerned, a moderate sort of a question. If we know how to calculate this value P, shouldn't take more than 2.5 minutes. What is the remainder when 4 raised to power 2020? 4 raised to power 2020 is divided by 17. 4 2020. Just square the 4. So 4 square raised to power 1010. This becomes 16. 1010. 16 is 17 minus 1. 1010. So the remainder here will be minus 1 raised to power 1010, which is even therefore 1. And that is the answer. Easy question, shouldn't take more than a minute, minute and a half. And therefore, if you look at the overall moderate level of difficulty paper, 6 questions, net correct is required. Attempt time may be a little high, and the attempt that I would go for is 2, 3, 4, 6, 7, 10. Which are these questions? Not attempting that in the paper. Definitely doing this direct application of formula. Doing this as well. No high funda required for this question. Again, because we've done this kind of question many times, maybe could have attempted this as well. 4 or 5, taken a call. Out of them, attempt 1. 6 would have probably attempted this as well. More so because 76 unit digit cyclicity, the 2-digit cyclicity was 76 is very obvious, and therefore was attempting this question. 7, I would have attempted basic question. This, I think, can create a problem in the exam, could have been left. Again, unless you know PNC not doing this question, this 10th was a sitter. So basically 2, 3, 4, 6, 7, 10. Some of you might look at swapping 4 and 5, but that's your call. For me, the 6 question will be 2, 3, 4, 6, 7, and 10.